Hey everybody, welcome to the second lesson in our current unit called counting methods. Again, this unit's all about just figuring out the number of ways that we can do things. Yesterday we learned something called the fundamental counting method. Fundamental counting method gave us a quick and easy way to figure out the number of ways that we can do things. Today what we're going to talk about is something called permutations and factorials, and we're going to see how that links to fundamental counting principle from yesterday. Now, before you watch this video, I need you to do something. There's another video that I'm going to share called How to Find on my calculator factorials, permutations, and combinations for both the TI and the Casio. It's really important that you go and watch that video first, just so you know how to get to what we're going to do today in our calculator. Okay, so go watch that now, if you haven't already, and then come back to this video. If you have watched that, here we go. So what I want you to do here is I want you to pretend that I'm going to hand you 52 cards, and you're going to select 3 unique cards. So let's make it easy for all of us. Let's say there's a jack, there's a queen, and a king. So your job right now is to figure out how many different ways you could put these in a row. How many ways could I arrange them? So how many unique ways could I do this? So I could do this. I could do this. So your job right now is to pause the video, go and figure out how many ways you could do that. And when you're done trying, unpause, and I will be waiting for you. Have fun. Okay, you've gone and tried to arrange these things. I'm just going to continue on, and let's see if I can get them all. Okay, so now I'm going to put the queen in the first spot, and then I'm going to put the king in the first spot. So what you should have found was that there was only 6 unique arrangements of these cards. Okay. Now that you've got that, hopefully you had that. If you had more than 6, usually what happens is someone writes the same thing twice and doesn't realize it. Okay, your job now is again to hit pause on the video, and you should be able to answer all of the questions on the rest of the page. Hit pause. See you in a couple minutes. Okay, you're back. You tried all these questions, I hope. Let's go. How many possible arrangements did we find? There were 6. Okay, did anyone else find any more than you? Well, trust me, the answer is no. Okay, does the order matter? Yes, because I can tell the difference in the order. I can tell the difference. Think of it as you and 2 of your buddies standing in line. I can tell the difference if you're at the front of the line or the end of the line. The cards are non-identical, they're unique. I can tell again the difference between each card. I can tell the difference between you and your friend. Would it make a difference if the cards were identical? Yes. If, say, I had 2 jacks that were the same, I can't tell the difference between those 2 things, those 2 arrangements of these cards. So I'm definitely going to have something happening here, right? I can't tell the difference. So I would have less arrangements, wouldn't I? Okay, now linking what we did yesterday with today. How could you have answered this question about building a table? Well, fundamental counting principle tells me that I can multiply my options together. I've got 3 cards to go in the first spot, 2 to go in the next spot, 1 to go in the last spot. Hey, that's a lot quicker, because for G here, there is no way when I've got 6 cards that I want to build a table for just 6 cards. I would be there all day. So mathematicians are inherently lazy, and we find a better way to do things. Maybe that's not lazy, maybe that's smart. So I'm going to multiply these all together. And I pick up my calculator and I punch that in my calculator, and that should have said 712. Now, All of a sudden I hand you the entire deck and I say, okay, how many ways can you arrange all of these cards? Okay, well, I start building my pretty picture, and as soon as I start doing it, I start to go, oh, this is gonna suck, right? So, but I'm humoring my teacher and I do it. And I'm gonna skip over a bunch of times, dot, 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 3 times 2 times 1. Okay, now I could attempt to get that thing into my calculator, but what a pain in the butt. Okay, so there has to be a way for me to get this in my calculator, and there is. If you had watched the previous video that I asked you to watch about how to use factorials, that's what we're going to use right now. This in my calculator is known as 52 factorial. That exclamation mark there is called a factorial. 52 factorial. So a factorial is a shortcut way to write a string of numbers in the fundamental counting principle that go in order. Notice that it counts down by 1 all the way to 1. Okay, go ahead and put that in your calculator. You are going to get an absolutely massive, massive number. You get 8.06 times 10 to the power 67. Yeah, you would probably spend most of your lifetime trying to arrange these cards all in the unique ways. Okay, so a factorial, super slick way for us to write or to figure out answers. Okay, that's the important part so far. So I'm just going to skip over this little piece right here and go right to here. An arrangement, again, that tells me that order matters. They're distinct objects, is called, here's your new word for the day, a permutation. So a way to do something where order matters. Okay, we could list all of the possible arrangements, but we learned a better way using the fundamental counting principle. Now, but even that can be a cumbersome, a pain in the butt to write. So we discovered just a moment ago a new way to write it called factorial notation, which uses the exclamation mark symbol like that. So this is on my formula sheet. So what factorial notation tells me is I'm going to arrange n objects, and what I'm really doing is I'm counting down by 1 each time, all the way to 3 times 2 times 1. Okay, so it's a super, super handy tool, okay, especially when these things are just so big. There's so many objects. Okay, let's try this out. So the first example here is just what happens when I'm playing around with these things. Can I get them in my calculator? So the first one, 10 factorial. So again, you should have watched that video to figure out how to get these going in your calculator. So 10 factorial, I get a really large number. Okay, I want you to think, what does that even mean? 10 factorial means there's 10 people in a row. How many ways can they stand in a row? There's 10 cards in my hand. How many ways can I line up 10 cards? That's a lot. That's a huge number. Okay, B, go ahead, put B in your calculator. Take a second to do that. And you should get an answer of 132. Now, I didn't use my calculator, and I'm not trying to show off here, because I know something that you don't know, but I'm about to learn you something. Okay, what if I didn't have my calculator? Heaven forbid I forget my calculator on the day of the test, and I get this question. Well, here's what I'm going to do. I'm going to take 12 factorial. I'm going to rewrite it. 12 factorial is really 12 times 11 times 10. And I'm going to keep going, right? Times 9 times 8 times dot, 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 times 3 times 2 times 1. And if I do the same thing to the bottom, 10 factorial is really 10 times 9 times 8 times dot, 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 times 3 times 2 times 1. Well, look at what happens here. I can divide all of these numbers. What am I left with? Just 12 times 11. And what's 12 times 11? 132. So what I did in my head was this. This is what I want you to start practicing when you get these questions. I'm going to do it again. I'm going to expand the bigger. 12 factorial is bigger than 10 factorial. We all agree that 12 is bigger than 10. So I'm going to go 12 times 11 times, and I'm going to stop at 10 factorial. The reason why I'm going to stop at 10 factorial is, what do I see in the denominator? 10 factorial. These numbers divide. So what am I left with? 12 times 11. Guess what, my friends? 132. Now, this right now, why am I going 12 factorial divided by 10 factorial? You're going to see why shortly in one of the following lessons. Okay, so for now, I'm just practicing getting it in my calculator. C, the important thing on C is to make sure that you've got those parentheses there. Okay, again, I always use my math fraction button because I have it. If you have it, I would suggest using it. It's just one less little thing to make a mistake on. So go ahead, take a moment to get that in your calculator, and let's make sure we get the same answer. If we don't get the same answer, chances are you're putting this in your calculator wrong. If you got that in your calculator correctly, you should have got 22. Okay, again, why are we doing this crazy fraction with factorials? That'll become clear once we've done our next lesson. Okay, 0 factorial. What this says is I'm arranging 0 objects. So how many ways can I eat 0 donuts? One way. I can't. I'm sad. How many ways can 0 people stand in a line? One way. I can't. It's imaginary. Okay. So I want you to think about that when you're getting these kind of questions. I want you to think about. Sorry, I got interrupted there. So yeah, whenever you get 0 factorial, think of it as you're arranging 0 objects. So there's one way to do that. I can't. It's in my imagination. Okay, almost done. Now, we're going to look at number 2. Number 2, now I can't use my calculator. And again, these are strange looking questions. You're saying, like, why am I getting these weird factorials here? And why are they asking me this? That'll become more clear as we start talking more about what a permutation is, and actually later on a combination in a little bit. Okay? But for now, play along with me. So it says simplify. So what again I'm going to do is I'm going to break up the bigger until I see the smaller. So the bigger is n factorial. Like, I hope you all agree that n has to be bigger than n minus 1. So I'm going to expand the bigger, n times, and then I take 1 away. And I stop right there. The reason I stop right there is, what do I see in my denominator? N minus 1 factorial. These two things divide to 1. So what am I left with? Just n. Okay, so I'm expanding the bigger. Expand the bigger until I see the smaller. Okay, next question, B. Let's go to pretty green. Which one's bigger? N plus 1 has to be bigger. So I'm going to expand the bigger. So I subtract 1 each time. N plus 1 subtract 1 is n. N subtract 1 is n minus 1. And I stop right there because that's what I see in my denominator. L divide O, that's 1. And what am I left with? Simply n plus 1. Again, you'll see why we're working with these crazy looking factorials here when we're dividing as we go through the next following lessons. Now, last little thing here before I end this lesson and we move on to our practice. So you've got not too much to do. We're going to do 2 more. And then in your practice, you don't have too many questions to do. Okay, so this one says solve. So solve, finally, I can actually answer a question. What's n? Again, this will be clear to you why I'm asking you to do this in a couple lessons. So what I'm going to do to solve this thing is I'm going to expand the bigger until I see the smaller. So n minus 1, n minus 2 factorial equals 20. Divide, okay, that's 1. So now I'm left with n minus 1 equals 20. Well, this thing's starting to look like a quadratic, so I'm going to multiply my n, distribute it. I'm going to bring my 20 to the left-hand side. I'm going to make sure I keep that equal to 0. I'm going to factor. And now I can solve. Therefore, n is equal to 5, or n is equal to -4. Now, I need you to stop and think here for just 1 second. This is important. N is the number of objects that I'm arranging, that I'm putting in a row, say. I can certainly put 5 objects in a row. Can I put -4 objects in a row? Well, that doesn't make sense. I can't arrange -4 of my friends. It doesn't make sense. So what I want you to do is cross that off and say extraneous. You can never arrange a negative amount of objects. That is a big, big deal. Okay, so you're going to get a couple of these in your homework as you go through, practice these things. Okay, check my answer. I take the 5 and I sub it back in to here. And it better say 20 or else I did screw up. Okay, last question. Determine the number of arrangements. Hey, there's that word again, meaning order matters, that 6 students can form while lining up. Order matters because I can tell if I'm at the front of the line or the end of the line. So if, again, I want to do this, I can use this, write this in several ways. I can do fundamental counting principle, or I can write this in factorial notation, or I could say that's 720 ways. One of the things we want to work on as we go through this unit is being able to write our answer in different ways. As a bit of a lead in to the next lesson, there's going to be a 4th way to write this. I am going to call this thing a permutation, and you will see that in our next lesson, I'm also going to be able to write this like this. So again, make sure that you've used the video above that shows you how to access these buttons in your calculator. Okay, my friends, I hope that went well, and I will see you soon.